Hello everybody, welcome back. A new chapter, and a very important chapter, because this is really where we get into the really practical parts of statistics. Because if, for example, if you get into a consulting job, maybe you'll have to do this, and we're going to see some of the problems that you could very well see in real life, because your employer might ask you, we want you to test this claim, and it'll be up to you to test it. So we've, in the last chapter, we were able to get estimates for a population mean, let's say. In this chapter, we're going to, instead of that, we're going to evaluate claims that someone else makes about a population mean or some other parameter. And that's what we want to do. And then we want to say, with this amount of confidence, we say that this claim is either true or false, or we don't have enough evidence to support or reject it. So that's what the hypothesis testing is. So a statistical hypothesis is a statement about a population parameter, like a mean or a standard deviation or a population proportion. So these are all examples of the hypotheses that we'll be working with. And then in particular, we're going to be working with two types of hypotheses: a null hypothesis and an alternative hypothesis. The null hypothesis is a statement that contains some notion of equality. So it has to have either an equal sign, less than or equal sign, or greater than or equal sign. And we denote the null hypothesis H0. And we call this null because we're going to start with that. We start assuming that it's true, and then we're going to decide, well, is this true or not? Or can we reject it or not? So, we have the null hypothesis could be a claim, it might not be, but it has to have a statement of some kind of equality in it. Then the alternative hypothesis is the complement of the null hypothesis, and we denote that by HA. And this will contain either the not equal sign, strictly greater than sign, or strictly less than sign, but it has to be the complement of the null hypothesis. So that means exactly one of these statements is true. So an example would be like if H0, if the null hypothesis says mu equals 5.7, the alternative hypothesis says mu is not equal to 5.7. If HO says sigma is greater than or equal to 3, then the alternative hypothesis says sigma is strictly less than 3. Okay? If HO says P, population proportion, is less than or equal to 0.75, then the alternative is P is greater than 0.75, and so on. Okay. And so, as I said, in hypothesis testing, you have one decision, and one decision only. You have to, if you're assuming that the null hypothesis is true, and then after you do your sample and you evaluate all the numbers, you're either going to reject the null hypothesis or you're not going to reject the null hypothesis. Okay. And if you reject the null hypothesis, if you say there is enough evidence to say that this null hypothesis is true, then you can say that then there is evidence to support the alternative hypothesis. If you don't reject the null hypothesis, it's basically saying your test is inconclusive. So there's not enough evidence. That doesn't necessarily mean that the null hypothesis is true in this case. It's just that there's not enough evidence to reject it. So this is the, there are two ways you could be correct in this process, or you could be incorrect. Okay, you could say if the null hypothesis is true and you don't reject it, that's correct. If it is true and you reject it, then this is called a type 1 error. If the null hypothesis is false and you fail to reject it, that's wrong. That's a type 2 error. And then if you reject the null hypothesis and it's false, then that's a correct decision. Okay, the way to think about this is the type 1 error is more active. You're actually doing something. With a type 2 error, you're failing to do something. And we are going to focus on, what is the probability that we are making a type 1 error. And we use something called the level of significance when we test our claims. This is the maximum allowable probability of making a type 1 error. So you'll see on some of these problems to evaluate this claim with a level of significance of, let's say, 1%. Well, what we're saying is that there's a 1% chance we're making a type 1 error. That is, if we reject the null hypothesis and the null hypothesis is true. Okay? So that's what we mean by level of significance. Okay, so another way of thinking about this type 1, type 2 stuff is, and this is similar to what we're doing when we evaluate a hypothesis. Okay, we're assuming the null hypothesis. When you're on a jury, okay, you're supposed to assume that the defendant is innocent, okay, until proven guilty. Okay, and so if you convict a guilty man, that would be a type 1 error. If you fail to convict and he is guilty, that would be a type 2 error. Okay. Also, just from in this sense that if you vote not guilty, you're not saying that, yes, we're not saying we believe, we're convinced that the defendant is innocent. You say there's not enough evidence to overturn the initial assumption that the defendant is innocent. Okay. All right. So that's what the type 1 error is what we're talking about here. So the game we play, and sometimes we call this, it might be helpful to think of this as a game, is that you assume the null hypothesis is true, and then go from there. And we'll see how does it have to do with claims in a minute. But let's see. Now, where is this? What do we do with this level of significance when we do when that we're given? Okay, if we want to put a bound on the likelihood of a type 1 error, what do? Well, we're back to using standard normal curves again, or at least curves, probability curves, and we use something called well, here's how the game is played. We always start by writing down our null hypothesis and the alternative hypothesis. And we start by assuming that the null hypothesis is true. Now, this is our null hypothesis because this has greater than or equal to in it. So we assume that, and we say, well, if we assume that the population mean is greater than or equal to k, then it makes sense that the most unlikely values, if we take sample means, the most unlikely values would be less than k. Okay, so the most quote-unquote extreme values would be less than k. And if we assume that all the sample means or the sample statistics are normally distributed or distributed like this, the most extreme values, unlikely values, would be over here. Okay, because we're assuming that these are if we're assuming mu to be greater than or equal to k. Okay, now we notice that k does not actually appear here. We just, and that's because we're kind of standardizing all this using a standard normal distribution in this case. So what we do is we this shaded region, if that's alpha, okay, alpha is going to be a certain percentage. And so what we're looking for is we're going to be looking and see if our standardized statistic is in here. And if it is, that is, if it's in this boundary, if it's past this boundary on this axis, then that's going to show that something's wrong, okay? Because if we're assuming that the null hypothesis is true, our sample statistic should be over here, okay? But instead it's over here. Okay. So you can think of this as kind of a rejection region. And this is because, this would be we'll call a left tail test, because we have, because the unlikely values would be all on this end, on the left end. Okay. Now, STS is a standardized statistic. That is going to vary depending what we're doing. Okay, what situation we're in, whether are we testing a claim about a mean or a proportion or something else. Similarly, let's say if the null hypothesis mu says mu is less than or equal to k, then the unlikely values for a sample mean would be greater than k. So the most extreme unlikely values for our test statistic would be over here on the right, and then this shaded region, if this shaded region has alpha, we say this would be our rejection region. So if we get a test statistic in this region, then we might reject our null hypothesis. And then in the case where our null hypothesis says mu equals k, then we have that the most extreme values could appear on the left or the right. Okay. So in this case, we want this region plus this region to add up to alpha. Okay. So so then we would only reject the null hypothesis if our standardized test statistic would be over here or here. Okay. All right. So that's how the game is played. I know this seems a little strange. This is just the general. We'll get into the actual formulas in the next lesson. Okay. But that's the way so we're going to be using either a left tail test, a right tail test, or a two tail test, depending on what the null hypothesis is. If it's greater than or equal to something, we use a left tail test. If we say the parameter is less than or equal to something, we right-tailed, and if it's equal to something, we use the two-tailed test. Now, the claim that your employer gives you can either be the null hypothesis or the alternative hypothesis. It depends, does it have equality in it or not? Okay. But what do you do? Tell your employer. You don't go to your employer and say, oh, H0 is false, or there's not enough evidence to support H0. He won't know what you're talking about. So what you say is you talk about your claim that you're supposed to evaluate. So if your claim is a null hypothesis and you reject it, you're rejecting the claim, so you tell your employer there's enough evidence to reject the claim. If you don't reject it, you said there's not enough evidence to reject the claim. If your claim happens to be the alternative hypothesis, which is that would be if your claim is something like mu is strictly less than 5 or some number, or strictly greater than 5 or not equal to some number. Then the claim is the alternative hypothesis. So if you reject H0, you can now support the alternative, so you say there's enough evidence to support the claim. Okay? You can support it because the claim is the alternative hypothesis. And if you don't reject the null hypothesis, again, it's inconclusive. You tell your employer there's not enough evidence to support the claim. Okay? You can only support the claim if it's the alternative hypothesis. You can only reject the claim if it's the null hypothesis. All right? So let's look at some examples how we could set this up. Well, you might see in real life here. So, a tablet manufacturer claims the mean life of the battery for a certain model is more than 8 hours. Now, the claim says it's more than, that means not at least, it's strictly more than. Okay, so we're saying that if mu is the mean, we're saying that mu is strictly greater than 8. So that's the claim. But this has strict inequality, so this has to be the alternative hypothesis. And then the null hypothesis would be the complement of that. So H0 would be, say mu is less than or equal to 8. Okay? And then this would be the claim. Okay? So the way you would do this is you're either going to have enough evidence to support the claim or not support it. And because we're assuming this to be true, the way we do this is we assume this to be true at first, so the unlikely values of the means would be greater than 8. So in this case, all the unlikely values would be over here, so this would be a right tail test. Next example, if the standard deviation of a base price of an all-terrain vehicle is no more than 320. No more than. That means it could be equal to 320, but no more than that. So what we're saying is the standard deviation is less than or equal to 320. And because this has equality in it, this has to be the null hypothesis. Okay, so this is our claim that we're going to test. And then the alternative hypothesis would be the complement of that mu is greater than greater than 320. Okay. All right. So once again, we're assuming this to be true. So the unlikely values of our test statistic would be greater than 320. So it would be on the right end. So once again, this would be a right-tailed test. Okay. The only difference between here, hopefully you see the difference between here and here. Here our claim allows for equality. In this case, it didn't. So that's why the claim here is H0. Number 3, 73% of college students did not use student loans to pay for their college. So this is really a statement about the proportion of the population of college students that did not use student loans. And what we're saying is that 73% did not use student loans for college. It didn't really say anything about, we're not really saying that something is greater than or equal to or less than or equal to, right? So basically the claim says that P is equal to 0.73, okay, where P in this case would be the proportion not using student loans, okay? Well, the complement of that would be P equals 0.73, okay? Or actually, I'm sorry. Let's try again. Try again, Blackridge. Should be. We're saying P is a proportion not using it, so the claim says that P equals 0.73. And then the alternative of that would be P is not 0.73. And this is our claim. Okay. Here. And so because we have equality here, the unlikely values could be on either end. So this would be a two-tailed test. Okay. All right. Have to define what P is, but we made it there. Next example is, okay, sorry about that. I had to answer the phone. So a repair shop claims that the mean cost of repairing a phone is less than $75. So here we're saying that the mean is less than something, strictly less than 75. So that has to be our alternative hypothesis. The null hypothesis would be that mu is greater than or equal to 75, right? Okay, and this is our claim. Okay, so because we're assuming this to be true, our unlikely values would be less than 75, so this would be, we would use our left-tailed test. Okay, so this would be over here. The unlikely values would be over here. And then in this last one, more than 40% of households struggle to avoid basic necessities. If we let P be the proportion of households struggling, okay, like this, then the claim says that P is greater than 0.40, greater than 40%, or P is greater than 0.40. Okay, so that's our claim. And because this has strict inequality, this is our alternative hypothesis. And our null hypothesis would be P is less than 0.40. Okay, and this would be a right-tailed test. Because we assume this to be true, so the unlikely values would be over here. Okay. Now, the idea here is all these shaded regions is equal to alpha, the level of significance. Now, how do we actually, what we're really interested in is finding what is the number here that corresponds to this boundary. And that's going to depend on what curve we're using and what alpha is. Okay. So that's what we're doing. But I just want to use this video to show you the basic shape of the strategy to know what the null hypothesis is, the alternative hypothesis, and how to determine which one is the claim that we're evaluating. Okay. So go ahead, do the exercises, and get a little practice. Think about it, and I'll see you next time.